Students, we are expected to solve this question. Foremost, what I wish to do is I would like to rewrite 4x squared positive 8x positive 13 as a perfect square utilizing 2x positive 2. So this is 2x positive 2, you expand this, you get 4x squared positive 8x positive 4, but we need 13. So I would add a 9 there. And when I do that, I will clearly get the left hand side. So this is rewritten as integral sine inverse of 2x positive 2 divided by square root of 2x positive 2 raised to the power of 2 positive 9 times dx. Now the next step would be, let me take 2x positive 2 to be equal to say 3 times of tan theta. Why? I'm trying to get rid of this 9 here. So if you were to do that, you differentiate this, you get 2 times dx is equal to 3 times differential of tan theta is secant square theta d theta. We don't have 2 there, we just have dx, so I will extract this as 3 over 2 secant square theta d theta, which will be equal to dx. So the question is rewritten, probably I will rewrite it here, is equal to integral sine inverse of 2x positive 2 is 3 times tan theta divided by square root of 2x positive 2 is 3 times tan theta. That would give me 9 times tan square theta positive 9, and in place of dx you have 3 over 2, so I'll place this 3 over 2 here multiplied with secant square theta d theta. So this is equal to 3 over 2 integral sine inverse of 3 times tan theta. Now 9, we can take the 9 out, that will become 3. So square root of 1 positive tan square theta multiplied with secant square theta d theta. So clearly the 3 and the 3 gets cancelled, giving you 3 over 2 integral sine inverse of tan theta. Now we have a formula, secant square theta negative tan square theta is equal to 1. So 1 positive tan square theta is equal to secant square theta. So we got root of 1 positive tan square theta is going to be secant square theta multiplied with secant square theta d theta. So square root of secant square theta is secant theta. So you have 3 over 2 sine inverse of tan theta divided by secant theta times secant square theta times d theta. Okay, this is what you got. So now let me use this part. This is 3 over 2. Now sine inverse of tan theta is going to be sine theta divided by cos theta. There is secant theta, you can write that as cos theta multiplied with secant square theta d theta. Now cos theta goes off, giving you 3 over 2 integral sine inverse of sine theta times secant square theta times d theta. Sine inverse of sine theta, that goes off, giving you 3 over 2 integral theta times secant square theta times d theta. Now let me take u is equal to theta, so du will be equal to d theta, and dv is equal to secant square theta times d theta. So integral of this b would give me, integral of secant square theta will give me tan theta, right, because differential of tan theta is secant square theta. So utilize this formula, u v negative integral v du, u is theta, my v is tan theta, negative integral my v is tan theta, my du is d theta. So this is equal to, let me move here, theta times tan theta, negative integral of tan theta. Integral of tan theta is going to be ln of secant theta. Okay, so now the question comes, we will have to revert everything back. Right, so I've got the value here, tan theta. What is tan theta? Now first I will have to extract the value for theta. So let me use this side. So from here this is 2x positive 2 divided by 3 is equal to tan theta, fair enough. and theta will be equal to tan inverse of 2x positive 2 divided by 3. So that is value of theta. So this is going to be tan inverse of 2x positive 2 divided by 3, that is for theta, and tan theta is going to be 2x positive 2 divided by 3, that is for tan theta, negative ln modulus secant theta. Now we will have to get something for secant theta. Now let me use this side of the page. Now I just extracted the value of tan theta. Tan theta is 2x positive 2 divided by 3. Tan theta is equal to 2x positive 2 divided by 3. So secant square theta negative tan square theta is equal to 1. Secant square theta is equal to 1 positive tan square theta. So secant theta is equal to root of 1 positive tan square theta. So this is equal to root of 1 positive 2x positive 2 divided by 3. This is raised to the power of 2, this is raised to the power of 2. So this is going to be root of 9 positive 2x positive 2 raised to the power of 2. That will give you 4x squared plus 8x positive 4 divided by 9, which can be rewritten as root of 4x squared positive 8x positive 13. Root of 9, that's going to be 3. So I'm going to write it as 3 over here, and this is equal to secant theta. So in place of secant theta, we will have to write 1 over 3 times square root of 4x squared positive 8x positive 13. Right, positive arbitrary constant c. So this is what we have to do, but we need to cater to this 3 over 2. So that means the 3 over 2 will be coming all through, because we do not consider this 3 over 2. So therefore, if I were to take this 3 over 2, the final answer will be 3 over 2 times tan inverse of 2x positive 2 divided by 3 times of 2x positive 2 divided by 3, okay, plus or negative 3 over 2 times ln, there's already a, anyway, I don't want to complicate this further. So this is 3 over 2 times ln of 1 over 3 root of 4x squared positive 8x positive 13. The square root extends, and this positive c. This is the arbitrary constant c. So that is the solution for this question. Okay, so you can go through this, and of course you can actually bring this over here and do some manipulations. But I think this is a good place for us to stop.